So now for the last bit, I'm going to try to integrate the petrophysical data, the production, the PLT data, which we haven't read, and the pressure data into one petrophysical plot. Okay, so let me save this, and I'm going to start with my empty template again.
Sir, one question is there.
Yes.
Yeah, sir, your folder contain last files, plus also there are two files .asc. So can you more elaborate about that?
Some files, let me see. This as ask ASC. I don't think they look at the files.
Yes.
I don't. These are almost like headers. There's nothing in there. So just headers. But I think most of the information it's not so much information here. Most of the files are in the last. Much of the information is in the last file where you have a pump capacity and you have quite a few information here. So everything is in here. Probably you have some other metadata in those ASCII files.
Okay, great, sir.
Right. So now let's do the last exercise, which is I'm gonna call it integrating file data. This is kind of a big one, and so we're going to integrate production logs, petrophysical interpretation, and pressure data in a graph for one well. So big title, but let's roll with that one. So for that, for this session, for this part, we're going to use WLI again. With WLI, we can read some of the PLT data, and we will use pandas for sure at some point. We have to use NumPy at some point, and I prefer to leave it as I'm pretty sure that we will use matplotlib. For those sessions. So let's first read the log data. And when I mean the log data, it's a petrophysical interpretation. And the petrophysical interpretation, it's all in multiple last files. So if I go to the petrophysical interpretation of that well, so I have a header or an ASCII file, very small with some information. There is a petrophysical report, which is quite interesting because from that report you can get from the input data into the output. All the calculations are mentioned there, so it's quite interesting. And we want to get we want to read this file here. So this is the petrophysical interpretation with the permeability, the final porosity, sand flag, and water saturation, at least among others, but that's what we're going to use. Okay. So that log data, it's let me see, is this file. So let me just copy that path. Okay, I'm going to read it in raw format. So, and as we go forward, we'll put more of a, this is useful function, so let me put it here. Okay. So I want to import that PLT, the PLT data, sorry, the log data. So step one, I'm going to start actually the other way around that I plan, but let's load. Let's load first a PLT log for that well, and then we will load the in a second step. We will load petrophysical interpretation, and this is a markdown. And for the third one, we will load the pressure data. So I have a log path. That's I already showed you that. But if I go to the pressures, so there is inside well logs, there is a pressure folder. Not pressure, sorry, production data, production logs. There is a production log folder. And in that particular well, I'm going to use this PLT from November 2014. Okay, I'm going to use this file. So let me copy this file. And I'm going to put here PLT. And in order to read that log, I'm going to use, actually, I'm going to use Lazio. Okay. So let's say I have a Lazio. And as we saw before, we have to use read. And I have a PLT. Okay, so we have that log there. And the other thing that I want to read from that log, if I go into the file, let's see if I can get the header. I want to read this particular date. Okay, so from the header, let's say I want to read header item, the date. Let's see if I can do this. And let me extract the last item. And I'm going to extract the last value because I want to use that. I want to use that date later on. So this is a PLT. Oh, okay, but this is actually not the date. This is not useful because that's not the date of the. I thought that was the date of the actual PLT acquisition. So it's not the actual PLT acquisition. So I prefer to set the date as 1st of November 2014 for the time being, just to make sure that later on when we plot, we have the right information. Just to get some more information from the logs or from the production log. So this is what we have in there. And usually, if I show you, some plots, let's get some of those plots. Actually, let's get everything. And I'm going to make a big plot with all that information using Matplotlib. And I want to get as many plots as the number of variables here. Okay, so I have 0, 1. I don't know how many I have, but I want to generate a graph with all those with all that information in there. And let's see how that goes. And let's put here that my figure size, it's 20 times 5 as the previous one. So for log in every one of these files, I want to produce a plot in this axis. So let me add an enumerator here. Enumerate this. And I want to add here a plot of the key, whatever key I want to get, WPLT. Well, want to add a plot of log versus the depth, which I think it's WPLT. Depth. Let's see if that works. Let's print here. Oh no, sorry. I need to call this key. I need to call this key here. PLT of log. Let's see if that works. Yeah, okay. I always get confused between these two, but I think if I do that, I should get a more larger plot. And the other thing that I'm going to do for the time being, it's multiply this by -1 just to get the depth, because it's the other way around. It's showing the depth the other way around. Well, I can invert the axis actually. Let's use Matplotlib. I can set this to invert. I think invert axis. Invert y-axis. Okay, and the other thing that I'm going to do, it's I'm going to change the style. I like to change the style a bit, improve the style of the plot. So I'm going to use style.use, and I think there is I can use seaborn style. I'm going to use seaborn dark grid. And if you see how it looks now, you see if that makes a change. So there we go, a bit of a change of style. And we can see here you can probably set the title. To the actual name of a log. There we go. So some of these are, you have an indication of how much oil and total fluid production through the different formations from the bottom to the top. Water production. You can see also that there is an indication of cross plot. Some of the formation, they have a positive influx of water. Some other formations have negative value of water, showing that there might be some thick zones in this well. So, but that's fine. And the problem is that this is fine by itself. But what I would like to do, it's have a look at some of these along the petrophysical information, if that makes sense. And I'm going to carry on now with the petrophysical information. So for that, let's use WLog. I'm going to use WLI. I'm going to use WLI.well, and I can use from last and set which last file I want to read, which in this case is this, oops, log path. So let's log path. If I see what we have in here, actually, let me add another line here. WLog.data. You can see all the information that it's in that log. And similar to what we did above, I'm going to use, I'm going to produce a plot of, let's see if I can produce a plot of the whole data. I don't know how that would look, but I think that there is a possibility to do this automatically. And you see that all that data, it's, I don't know why, but there are lots of probably not not a number values in the data. So one thing that we can do, it's plot the data by segment. So if I take, for instance, let's say that we want to generate a segment for porosity, segment for porosity, there is this WLog data. I can extract porosity, and I can set, I can change the range using two bases. And I think there might be, let's see if I can put 3500, and let's see if that works. 3800. No, I think I need to, okay. I was just checking if I need to specify these variables here. Okay, so now I can do a segment. So if I do a segment dot plot, yep. So now the data, the plot is clipped to that range that I have specified. And that's fine. We have imported the log, and let's say I want to have a plot of let's do something like, someone is writing, no? Okay. So let's do something like I want to create a plot with some variables here. So I want to plot permeability. I want to plot permeability. Phi, sand flag, and also water saturation. Okay. So for plot into plot, let's add, as we have done in previous in this exercise. I want to make a plot with all these variables that I'm going to plot. Okay. And I'm pretty sure that I need to enumerate or add a counter here. And what we would like to do, name, could you check your name tag, the blank one? It partly blocks the view on your window. I don't know, it's which part of the window is being blocked. Is anyone having issues with the window? Can you see all the screen? I'm not quite sure. Yeah, I'm not quite sure what is the issue. Yeah, I don't have anything blocking the. Okay, I'm gonna carry on. Just let me know if you see any problem. So now, as I mentioned, I want to produce this segment for all the plots. So I want to create a segment for every plot, and using that plot, okay, and let's use segment.plot. Actually, instead of segment.plot, I need to specify in which axis I want to plot it. So I can say I can set up the axis here, stating that I want to iterate through the axis. So let's see if that works. Hey, here we go. It's fine. So we have the permeability log clipped to that start and that stop date. Depth, and we have a sand flag. If I would have to do something else, which I will do later on, is change the sand flag to something more. Let me change the sand flag. Well, I'll do it in the integration part. I'll do it in integration part. So now I have a pressure data. I have a log data, the petrophysical data, and at the top I have the production logging data. And I think you can see where I'm heading. I want to integrate all this information, but before I do that, let's integrate the PLT data. So the PLT data, not the PLT data, the pressure data. Unfortunately, as I mentioned, I am not in this section. I didn't identify. I haven't get to the point where I identify the pressures. So I'm going to be a bit cheeky, and I'm going to take the actual pressures from the file. And for that, I will use something that we have used in the past, which is a library called Tabula. And I'm going to get that information from that report, which is if I go into the well logs, pressures, and this particular well, I want to get this report. Let me copy this path. And I'm going to put here, this is my press path. Right? So I have my pressure report there. And let me load this as well. So if I do table equal to tabula, and I can write here press what happened? Press log, it's not there. Press path. Oh. Press path. And I know that I want to read the page 5. Object is not callable. I think I need to use, sorry, I'm using the function, the tabula. I need to do tabula. Read PDF. Okay, what's the purpose of tabula? Tabula, it's a PDF reader. So you can, in this case, we have the PDF report, and because I didn't extract the actual pressure data from the graphs, I want to read this table into Python, right? So I want to convert that table into a data frame in Python so that I can use later on. So that's all the purpose of Tabula. Okay. So does Tabula convert the data? The Tabula, it's not an OCR because the OCR, if it's an image, it reads through the image. But if it's in this case, it's actual data. So I can actually copy and paste this data, this table. As you can see, the values are there. I can copy and paste the data from the report. But if it's not really an OCR because that is an actual table inside the PDF with some tabulated information with some numbers and so on and a header. So it's actually much more simple than an OCR. There is something going on here. I don't know why it's not reading my pressure report. I'm not sure why it's not reading my pressure report. Let me see what's going on here. I think that I'm in the right report, the right folder. That seems to be fine. And let me see what's going on here. So table equal tabula dot read PDF. That's fine. I'm stating which path it is. I need to specify pass the argument pages. So it's not a default argument. So it's pages equals to the page that I want to read. And this is giving me a lot of messages here in the background. And the reason is that this is actually using, or the library was written in Java. And I can, as you know, you can suppress messages from Python. So I could do something like at the top, I could do something like this. I can filter warnings and I can ignore the warnings. But actually not going to work with this because these messages are coming from Java. So one thing that you could do is put silent equal true, and that should be fine. So if I have a look at the table, there we go. So we have the table in the already as a data frame in Python. Right. So let me see where we are. So we have now the production, the logs. So I have a log, I have a petrophysical data, and I have a pressure, which I'm not going to go through a process of plotting the pressure in a plot. That's not the point. But what I really want to go is to step number 4, is the integration. And in order to do that, the first thing that that we need to do is set up the everything to the same reference. So if you can imagine that the logs are probably at a frequency of half of it, while the PLT data, I have no idea what's the frequency of a PLT data. We can have a look at it, but this is the last file. Actually, it's even it has higher frequency. Actually, this all is in meters. This is every 0.1 meters. I'm not quite sure what's I guess the frequency of a data is of a logs is still 0.5 feet in meters. And the pressure data, as you know, as you can see, it has very different values here, no? So there is not really a frequency because you are targeting particular formations and while drilling, and it's not with a common frequency, as you can imagine. But we have to put all this data in a common format. So the first thing that I'm going to do, it's one plot that I like was this one, and I'm going to convert this plot into a function. So I'm going to write here my useful function, and this is I'm going to call it my plotting function, which I'm going to pass a start, stop, and the to plot. So the list of items to plot. So the only thing that I'm going to do here is to have this useful function for later on. And something that I would like to do here as well is, you know, if I have that sand flag, I don't like this sand flag in the way that it is, because this is just telling me what is the type of flag that I have, what is the type of sand that I have. So I don't like that log. So what I'm going to do in this function is if the plot is a plot of sand flag, I'm going to plot it with the following segment dot 2D, and the rest is the same. Axis, and I need to put what is the color template that it's going to use. In this case, is I'm going to set it to. Let's forget about the color template. See if it works without the color template. So if I have this sand flag, please plot it in this way. Otherwise, plot it in the more common way. So if I run that function, plotting function, let's start with that. I'm going to do the plotting function from 3,500 meters to 3,900 meters, and I want to plot these variables. Yes, move this down again. And I'm going to call it for the integration later on. I may add some more stuff there. Let's see how that works. Okay, that's fine. So I have now the SAN flag, or the flags to the logs and so on. I can set the range, which you will notice that it will be extremely useful as a function to use that later on. And the only thing that I don't like here either, it's that I'm missing the title here on the log. So I'm going to just make sure that when I use a function, the title also come. I'm going to force the title even if I don't have it. And the title is going to be exactly as the name of the plot. Just make sure that I have a title here. So far I haven't integrated any of the data, but I think I'm moving into something that it's nicer to visualize. Okay. So first step to convert the PLT data. So as I mentioned, the PLT data has a frequency and a range that is different to the petrophysical data. So I want to bring everything into the same range. For that, let me just remember how I did it. Okay, so if I bring the WPLT data, and let's bring only one of the properties, QOZI, is that one of those? Okay, there we go. So we have some values there, some NAs. And one thing that I would like to do is if I want to add a plot here, I want to make sure that it's in the right scale. So let me just remember how I did it. So I'm going to store this PLT data called QOZI. It's going to be equal to, I want to get rid of all those NA and NANs from the data, and I'm going to use a quick list comprehension. Just replace by 0 if I have, and if I don't have numbers, if so if I have NANs, not a number, I'm going to replace those by 0. Otherwise, I'm going to keep the same values for X in this range of data. So if I print this, you will see that's very important later on. Okay. Now, I want to add this to the logs. Let me clear this out for just a second. I want to add this to the logs. So ideally, I should be able to do in the petrophysical log .data, I should be able to do something like, I want to bring the PLT dash set I should be able to do something like that with WLog. And there is, I try to do this. I try to straight away add this into the mix. It accepts the values, but however, when I try to do it later on to plot the information, I couldn't plot anything. So the right way to do it is to add it as a WLog curve, because remember that this is a WLog instance. So I can add it as a WLog curve, and plt.qSetI. Yeah, that's fine. And in fact, I can explore what is in there. Yeah, so I can see the depth, which is quite strange. Oh, the depth is just samples of data. And this number seems all right. The range seems all right. But the problem is, at the moment, I don't have any reference to the depth of this. So I added that log, but I don't have a reference to the depth. So in fact, it added the depth as 0 to 860. But we know that the depth is actually whole. The depth of that log is actually whole in here. Yeah. So we know the depth. We know where is the depth. So one thing that I can do is do a simple interpolation. So let's say here I'm going to add another step where I want to get the actual values interpolated into the domain of a log. So I'm going to call this PLT PLT That's interpolated, and this is equal to np dot interp, yes, and I want to state at which depth I want to clip these values. And if you remember, I should be able to use let's extract for a second WLog and the data. Let's see if we should have depth here, isn't it? Oh, I see. WLog. Where's my depth here? Or it's a index. Okay, I'm going to do something here before I can extract the depth. The depth is in an index. I am not quite sure how to extract the depth from the index, but I know that I can convert this log into a data frame. So let's store this log temporary as a data frame. Okay, just a second. What happened here? Okay. And if I have a look at that, okay, now I have a depth, and I have a depth, and I have all the properties. So now I can do the interpolation. So I can get the depth from the actual index. Dot values. And remember I don't know if you have seen the interpolation from NumPy, but you need to give the x at which you are referring to. In this case, I would like to re-reference all my PLT log to the depth from the petrophysical log. So that's the depth from the petrophysical log. And this XP and the FP are in this case, are the production log, the depth and the actual value. So I think I should be able to do W from the PLT, get the depth, and I can use this property that I corrected here from with zeros and ones. Let's see if that works. And let's put this in here. But before I do that, let me show you something. So if I have a look at the length of this data, now I have 8,889 values, which is exactly the same number of data points that I have in my log. So with the interpolation, I managed to get everything to that same resolution. Of course, there are some other considerations that you may need to have. In this case, there is a consideration that you may need to have for which value you want to assign for values that are lower or greater than the range of a data. And you can use a left or a none here. Okay, let's add that to the log and let's see the statistics. Okay. So here we have now the data goes up to 8,888. Not sure what are 88 rows, which are equally spaced in 0.1 meters in the data. And in fact, if let me remove this cell here. In fact, if I call this function again, let's use this useful function here. And now I'm going to add this plot here. There we have a PLT plot in the mix. Isn't it nice? So now we are integrating, really going to the process of, we have the petrophysical data, we have the PLT data, and the last step that we need to do is integrate the pressure data and see if we can add the pressure data also into the mix. Okay. And I'm going to do something else at the end. So for the pressure data, I'm going to follow the same steps that I have following here. First, clean the not a number values, and then interpolate, and then add to the plot. So let me do this for the pressure data. And the pressure data, it's in a file called table 0. That's very bad name, but let's call it, actually let's call this wpress_df. Just make sure that I have it in a nicer location name that I can access. So I want to get from this file, and I want to get, let's see the columns that I want to, just a second. Let's remember that what we have in there. Let's remember first what we have in there. So in that data frame, we have MD and the pressure. I'm going to take the third pressure, the third stabilized pressure from every one of the stations. And so there are no non-numerical values here, so I really don't need to follow this step. And what I would like to extract is this pressure data. So I want to extract that pressure data. And let's follow the steps that we followed previously with the interpolation. Okay, so first we add the interpolation. Now we're going to, this is pressure. and this is pressure from the MWD, and the depth are exactly the same. And in here for the interpolation, I want to use this pressure, and I want to use the TVD. There's something funny here, and actually haven't realized before. Let me see here, table 0. Yeah, that's a bit strange because on the same well, you can see the logs, they are from 3,500 meters up to 3,900 meters, and that's where we have data. But the true vertical depth here is, I'm not quite sure if it's related to a subsea level, something that we need to modify, but I think that we're going to get out of a range of the logs, but we'll see in a bit. Now I have the interpolated data, and I'll do the same step that I did here. So I'm going to add now the MWD, and this is MWD pressure. And I'm going to add this data here. And let's do the plot again. But at the end, I will add that plot. And just as that is, okay. Yeah, as you can see, there is something going on there. I'm not quite sure what it is, and I'm not going to figure it out now. But the thing that I would like to do here is add some interactivity to that plot. So I'm going to add here, how would I do it? Let me add interact. This is using the widgets. I'm going to use some widgets inside Jupyter Lab to control the depth more interactively. Okay, so I'm going to generate a function which is called show or modify depth ranges. And that function takes, let's say, a minimum depth that goes from, I have to specify a tuple here, 3,000 up to 3,900 in steps of, it's 2 steps of 10 to make it quicker. And I have, let's do steps of 1. And I have a maximum depth. Let's specify the same maximum depth. Of 3,000 to 3,900. Now, the plot that I'm going to generate now, I'm going to return here a plot where I'm going to specify the minimum depth and the maximum depth, and the plot int is exactly the same. So let's see what happens there. Well, interact is not defined, so I have to import the functionality to add widgets. So import or from IPy widgets Report start. Okay, let's try to run this again. And if I run this, I can probably see in a more detail, edit the ranges at which I want to have a look. There is something definitely going wrong with that depth for the MWD. Not quite sure what it is, but I think you can see more of the applicability of integrating all data. So what we have done today, it's yes, we loaded the deviation service from the WithML from the WithML file, and we integrated the pressure data from the measure while drilling information. We also integrated the PLT data and the petrophysical data into a single canvas. And yeah, that's what I wanted to do today with Volve. So questions for the session today? Actually, before, I have a question for you. What else would you suggest to do? So if you would have the same data that you have, or you all have access to the data, what you would like to see done with this data? And if you have any other comments, I would like to hear as well. Something related to machine learning. Well, that's big. But specifically what? This is well, now we have all the data here, but yeah. The net to gross. Yeah, I guess so. There is well, that is a petrophysical interpretation. I think that you can have a look at the report and then work out the report. From the last session, Ankit, actually, on the last session, he was working on the raw data and doing the interpretation of the petrophysical data. So if you go back to that session, he has that bit as well. Rock type and a bit of MWD and LWD data. Okay. Oh, that is that for the. Oh, is that for the machine learning? Yeah, that. Yeah, I mean that you can with the petrophysical data you can do rock typing. I'm not quite sure if with the well with the logs. Once you have a logs, you can interpret the logs. You can do rock typing. Yeah, that might be something that we could do with this. Some projects using deep learning. Yeah, again, that's very big statement. What in particular, what projects you would like to see with deep learning?
Hello, Alejandro. How are you?
Oh, is there NSA?
Yes, I like this workflow, man. I've been trying to. Well, I've been doing this for many years, actually. Exactly the same workflow that you have been doing. I will just add the PNLs, which are the famous RSTs, production noise, production neutral logging, and that will give you even a good picture through the years. It could be different PLTs, different years, and one more thing apart from that will be the pressure from the pressure build-up test. That would also, that should be something easy for you to add as well.
So the RSTs, yes, the RST is actually quite straightforward because there is an RST last as well. So I can add that step. I probably need to understand a bit of this report because this is the saturation log. Yeah, one thing that I wanted to do also is have a look, extract the synthetic logs from the simulation file, which we have it, and then add it in the site, so to compare.
Yes.
And also I have my own objective functions,
exactly.
and you can have a whole.
I have done that side by side. I can show you a picture of that exactly from the simulation file, and it works beautifully.
What's your name?
Nelson.
Oh, Nelson. Okay, Nelson. Good, excellent. It says it's just that it says NSA, Nelson Acosta.
Yeah, that's my trademark name, man.
Man, I was scared. I was so careful.
No worries. We're watching you. Thanks for that. Huh? I appreciate it.
Okay, no problem.
Cheers.
Okay. Could you write some information MPQO, BSW, UR, etc. on a track? It's easy to understand the logging with updated information from the well. Yes, I believe you can add that information. So for a particular date, add some more information. Yes, yeah, absolutely, Rafa. So predicting NMR logs values with other logs data using deep learning. Can it be done? Yes, I think so. I'm not sure if okay, deep learning, it's let's say a neural networks on steroids, and I'm not quite sure if you would need deep learning so that many layers of a neural network to do that, but
if I can comment on that, anytime you want to do machine learning or artificial intelligence or deep learning, any kind of applications like that, you need to take into account that you need lots of data for those kind of applications. So if you don't have much data, probably it's not gonna be. Probably you can do some correlations and some simple stuff, but in order for those algorithms to work properly, you need large amounts of data typically. So it's a question of evaluating if we have enough data for those applications.
Yeah.
But it's interesting anyway. I mean, it's interesting to think about those applications because anyway we are doing correlations and all kind of things like that. So, and the advantage of doing machine learning, for example, vision models can grow and keep learning until you get something that is useful as you gather more and more data. So, I think it's interesting the idea. We just need to figure out what's the best way to do it.
Yeah, about sharing the files. Thank you, Adolfo. There was a bit of a noise when you were talking, but I think we could hear you. About adding sharing the information, I will add everything to the GitHub repository straight away.
Sir?
Yes.
So there is one competition is going on about the lithology predictions. So
Yes.
in the some of the wells, some of the channels of the log, entire channel is missing. So how can I build a model basis on that? Where
I guess the way I know it's you can get the information from, you can get the raw data from the log, and you can use supervised learning, meaning that you go through one log, you do your own interpretation, and you get all the input data. You use your interpretation as your classification, and then you train the machine learning. So almost like you have every point of your log, it's a data point for training. So that's you can train with one log. You can train all the you can generate a model, a neural network model, or any classification algorithm to classify your log, and then predict on the other logs. Of course, the more, let's say, the more interpretation that the petrophysicist put on it, so the more logs that petrophysicist actually is interpreted, and then later on you go through a classification algorithm, the more reliable the prediction will be.
It was, what if I do not have the data of or particular channel even in the raw data?
I didn't quite catch that.
Actually, suppose I have 100 wells, and in some of the wells I have resistivity data, and some of the wells I do not have some resistivity data. So I have to build a middle model based on all these data. So when a user puts in the data, it should give out the what kind of lithology it should be. So some if I have if I have some channel missing in the some part of the data, so model would not accept that data, no? Because if I have suppose I have 15 features, and in some of the wells I do not have seven features available, so how
Yeah.
would how would model predict based on that?
Yeah.
That is what
No.
I'm asking.
No, I understand that. I guess. Yeah. So you can still train models with less data and then try to see if you can get there. But yeah, if obviously if you have a gamma ray and that's all you have, then obviously you can use a model and try to train based on the gamma ray. But it's you cannot expect a miracle out of a machine learning. No, it's the machine learning will be as good as the training data that you have to fit it. And if you don't have more data that classifies your well, you just have a gamma ray. That's you're starting on a weak point. So this is not a silver bullet for all the problems.
Okay. And is there any method for the imputation, for the imputation of the missing 9 values?
I guess so. You can. Depends on, for instance, for the PLT, if you have missed data, well, you have to be very careful because you can use almost like the previous or the last data and try to get continuous data. It all depends of what you want to replace. I would tend to, if it's a production data, I would tend to just set everything to zeros if it's missing data. Rather than using average or mean. You can use median, mean, average, the most common value, mode, etc. But you have to put the criteria on it. But with pandas you can do that.
Okay. Okay, thank you, sir.
Rafa, I like your idea, Rafael, which is create a new track, which is that. I need to think about that. I'm not quite sure where is if anyone has seen the data. I would like to automatically get. Of course, I think there is a completion diagram somewhere, but that is in a PDF. What it would be great is to have exactly as you. From this step to this step, we have a perforation. We have a perforation here, so that would be great to have, and we can add time to that as well. So in a way, that's what I brought the date when I was importing all the data, because on a PLT it's important to get the date. Sometimes you do a PLT over several PLTs over a period of time, and you want to compare that PLT, that evolution of the PLT. So my plan was to put the name of a PLT log plus the date, so that you can add not only a depth slider, but you can add a time slider. So when you have multiple files, you can slide over multiple times. I have uploaded the session, the data to the. I have pushed all the data to the GitHub repository. Let me see. So it should be already on the GitHub repository. Any more questions? I think this is yeah, it's quite good to hear some of the suggestions, and I think yeah, everyone wants to go to do machine learning. I think that we need to start to crawl before we walk and before we run. So getting the data ready in a format that then we can use scikit-learn to use some machine learning. It's very important. Cleaning the data, understanding what you have in there before we do machine learning. And of course, in these sessions there are a mix of expertise. And okay, the session, yeah, all the data it's already on the GitHub repo, and I will be uploading at some point the video. Any more comments, questions? Good. So I'm going to disconnect. So thanks everyone for connecting. I think it was yes, we have a good questions at the end, and I hope you enjoyed the session. Okay, thank you.